Hello everyone and welcome back to this video on fine-tuning GPT-4o Mini. So while this week focuses more on fine-tuning open weights models that you download from Hugging Face and you will have to do everything yourself, I think it's a very good start if you learn how to fine-tune some model via a managed service, because you don't need to understand a lot of the things that's happening behind the scenes. So OpenAI allows you to fine-tune their models, and we will be doing this by uploading our data to OpenAI, and they will do the fine-tuning for us. So in this lesson, we will run the GPT-4o Mini on the dataset before fine-tuning, and we will see how it performs. And then we will fine-tune the model, run it again, and see if fine-tuning actually makes a difference. So let's see how we can do this. So keep in mind that in order to run this, you have to have an OpenAI key. So unfortunately, this is not free. So make sure you have your own key if you want to run this yourself. And we will have different stages. So the first thing that we need to do in order to do this is to prepare our data. So OpenAI expects the data to be in a specific format. They expect it to be a JSONL dataset. So in our case, we are still working with the configuration file. We showed this before. So if you look here at the config, this is what we're using. We're just passing in the name of the dataset. And this is what we are reading here. And then we have to put this in some format. This is what's done here by the prepare OpenAI JSONL. What this does is it downloads the data from Hugging Face, and then it creates a list of samples. So what OpenAI expects is a JSONL file where each sample is on one line, and each sample has to have a system message, user message, and assistant message. And this is what OpenAI expects. And you have to give them like the training file and optionally a validation file. So this is what we will be doing here. So if you run this script, you will see that it will have multiple options. The first one is to prepare the dataset for fine-tuning. So I will hit 1 and then run this. So you can see it's picking up the name of the dataset here because we are putting this in the config file. And then you can see the splits are saved in the data experiments folder. So if we go to data and then experiments, you will see we have the OpenAI files. Inside there, that's the name of the dataset, and then we have train and validation. Now, if you look at the training script, this is what we have. It's a JSONL. Each sample is on one line. It contains the system prompt, which again we define in the configuration file. And then you have the dialog, and at the very end you have the actual summary. So I'm not going to go through every little detail in the code, but basically this is what it does. And you should be able to do the same thing if you are strong in programming. I think it's a fairly simple task to convert a dataset into this format. Now that you have the data, what we can do is fine-tune the model. So before we do any fine-tuning, let's just run the evaluation first on the base model, and then we will fine-tune it and run the evaluation again. So here, I want to evaluate the base model. So I will be typing 3, and then it asks you either for the name of the model that you want to run directly or a fine-tuned ID. In this case, we haven't done any fine-tuning yet. So I will just type in the name of the LLM, and I will run this. So you will see it will start evaluating on the 200 samples of the validation set. And once this is done, we will have our metrics. So after evaluation is done, you can see we now have our metrics: 40% for ROUGE 1, 15 for ROUGE 2, and 31 for ROUGE L. And then these metrics and predictions will be stored in the files in the output directory. So if you go here, you'll see these 2 files created for you. And keep in mind, you don't need Colab in order to run this because nothing is running on your side. This is one of the advantages of using LLM providers, that you don't have to worry about running these things. And that's why I'm running this locally. So now we can compare this with what we had from the Llama model. So if you look here, this is the notebooks directory. This is our first lesson. So these are the results that we got from the Llama model. You can see ROUGE 1 was 35%, but for GPT-4 Omni it was 40, so it's better. For ROUGE 2 again, GPT is better, and for ROUGE L, GPT is better. So that shows you that these paid models are actually better than open weights ones, but this is at the cost of having to pay for these models. And the other advantage is, of course, you don't need to worry that much about running these models yourself. But also keep in mind that you had to send the data over the network to OpenAI, and for some applications this will not be possible. So yeah, if data privacy is a concern, you won't be able to go with this approach. Okay, so these results are for the base model without any fine-tuning. Now let's do some fine-tuning. So I want to run a fine-tuning job. For this I will type 2, and you can see it starts uploading the files directly. Remember, we in the experiments we created 2 files, train and validation. This code is set up to take in these files and upload them directly to OpenAI. So now these files are being uploaded, and then the job will start. So now the files are uploaded, and then the fine-tuning job started. So now if you go to the OpenAI console and you look at the fine-tuning tab, you'll see we have a job here that's working. Currently it's validating the files, and then it will start the actual fine-tuning job. This is the LLM that we're fine-tuning. These are the hyperparameters that we are using. In this case, we will just do a single experiment. So if you're curious what would happen if you change these, feel free to try it yourself. We are restricting it to a single epoch because these jobs are somewhat costly compared to just API calls to a normal LLM. Fine-tuning is more costly, and it depends on the size of your data and the number of epochs you choose. So we're keeping it to 1 just to make it cheaper. And you'll see that at the end, when this job is done, there will be some charts here that we will look at. So I'll pause the video here and I'll come back once this is done. So now the training job is done. If you scroll down there, you will see the loss and accuracy charts. You'll see generally the loss is decreasing, accuracy is increasing. And keep in mind that this is a strong model compared to the Llama 1B. So the loss starts from, I think, 4 or 4.1, which is considered a high number, but still the performance was very good. Like the ROUGE scores were good. So now if you see the loss decreasing, this means that the model is getting even better at this data set. And yeah, you can see there is the green curve and there is the purple one. So this is the validation loss. The purple curve is the validation loss, which is evaluated once every while. So you can see sometimes even the validation loss is lower than the training, which is generally a good sign. So yeah, this is how you fine-tune a model. And then at the end, they give you this model ID, which you can then use in order to call this model and get responses from your fine-tuned model. So let's see how it performs. So now we go back to our script and we want to evaluate a model. This time I will enter the ID, which means I will be fine-tuning, I'll be evaluating the fine-tuned model. So let's see. So now the evaluation is done, and here are the numbers. So you can take a look here side by side. This is the fine-tuned model, and this is the base one. So you can see in all of the ROUGE variations, the fine-tuned model is actually better. All the numbers increased. So this shows that the fine-tuned model actually performs better than the base one. If you want to take a look at the predictions, so these are the predictions of the fine-tuned model. Yeah, I would expect them to be very short because this is the style of the dataset. So for example, this is 1 generation. Let's take a look at this. Now it's a lot shorter again. So yeah, here, for example, this one. So yeah, again, it's short. So you can see the behavior or the structure of the outputs is completely different, and this is the result of fine-tuning this model on this data set. So I think that was good to know that you can fine-tune these models. The effort that you need in order to do this is very minimal. You just need to upload your data, and they will do it for you. So yeah, I think this was a very nice exercise. So that's it for this video. I hope you found that useful, and I'll see you in the next one.